How's it going, ladies and gentlemen? My name is Cazz and welcome back to the channel. Today I'm starting a CS2 internal multi-cheat series with the express purpose of teaching you how to actually create a CS2 cheat base. In this episode, we are going to go ahead and get started with our project. We're going to set it up and we are going to get a basic ImGui menu running. Now, I think that this is a very, very good step because it's going to allow us to set up the skeleton for our project, make sure that we can inject the DLL, and it's also going to get us involved with hooking and get us involved with the usage of source to CS2 interfaces. Both of those are very, very important topics when it comes to CS2 cheat development. Now, one thing that I want to say is that a lot of beginners don't understand that every CS2 cheat is actually the same thing. It's just being done in a slightly different way with slightly different flavors. And that's kind of the point of this series. In this episode, we're going to add a menu. In the next episode, we're probably going to use those rendering functions to start working with players and then eventually create an ESP. And finally, towards the end, we are going to be creating an aimbot and so on. Now, as per usual, the source code to this video is going to be available on my Patreon. So if you do want to support me and you have $3 lying around, then go ahead and check that out. That's much appreciated. But if you don't have any money, that's completely fine because at the end of this series, I am going to release the full source code on my GitHub. Now, every single episode of the series is going to depend on the previous one because we are going to build up the cheat base together and it's going to be a lot of fun. Now, listen, if you've never used C++ before, then this is probably not the video for you because you are going to get lost and you're probably going to have quite a difficult time following along. And on the other hand to that, if you have made a million cheat bases and you are some super elite anonymous hacker dude, then this is also not the video for you, obviously. The target for this is people who are kind of in between. Maybe you are working with CSGO and you haven't updated to CS2 yet. Maybe you are just getting into hacking and you have a little bit of experience. This is for you. I really want to teach you how to architect a CS2 cheat base and allow you to express yourself and do it in your very own way. Now, credit where credit's due, I didn't go and reverse engineer the whole of CS2 and figure this all out for myself. I used a lot of online resources such as existing cheat bases, and unknown cheats came in to help a lot. And whenever I ran into something that was outdated that I needed to fix for myself, then I hopped into IDA and I fixed it. And on that note, we are going to be doing a little bit of that through this series. I'm going to try and show you how you can update things because some things are going to be outdated if you are watching this maybe a couple months into the future. Now, with all that being said, if that sounds fun to you, if that sounds good, then I suggest you go and make a couple cups of coffee, get some popcorn, and stretch your fingers because there is going to be quite a bit of programming and coding and talking in this video. So with all of that out the way, I think I covered everything. Let's go ahead and hop into the creation of our project. Before we jump into all the code, I wanted to talk about a common game hacking misconception. A lot of beginners think that game hacking is simply a matter of being some sort of coding wizard, but they couldn't be more wrong. Hacking games is actually a test of your ability to solve complex problems, which can be a very difficult skill to develop. But that's exactly where Brilliant.org comes in. Brilliant's main goal is to help you become a better thinker with thousands of visual, interactive lessons in math, science, programming, AI, and a lot more. There's always something to explore. Brilliant has a focus on improving your critical thinking skills through interactive lessons and problem solving, not memorizing. That's my favorite part about their platform because I really struggle to concentrate on massive walls of text, which makes Brilliant's approach to learning really resonate with me. Now, don't get me wrong, coding is still an essential tool for anything to do with video games, and being a coding wizard will definitely help you. This makes Brilliant's growing collection of programming courses a great way to build some timeless problem-solving skills. So what are you waiting for? To learn for free on Brilliant, go to brilliant.org/Cazz. Scan the QR code on screen or click the link in the description down below. Brilliant's also giving my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on the platform. Thanks for listening and let's jump into the video. Alright gamers, let's get into setting up this project, but before we can do that, we do need to talk about the requirements. The first requirement, of course, is just a Windows computer. I'm using Windows 10, but this will work just fine on Windows 11. The second requirement is some sort of C++ build system, and in this case, we're going to be using Visual Studio, not Visual Studio Code. That is for femboys. We're going to be using Visual Studio. In terms of what you need installed for Visual Studio, you pretty much just need to scroll down a bit and install desktop development environment with C++. So once you have Visual Studio, which I honestly hope you had long before clicking on this tutorial, but we're going to ignore that. We're also going to be using ImGui for our rendering and for our menu. So head over to the GitHub in the description, go over here to releases and download whatever the latest release is. You can just download the source code like that. Now, the fourth and final requirement that we need after all of that fun stuff is minhook. We're going to be using this to place our hooks in CS2, and that's going to allow us to do all sorts of crazy things. Now, minhook stands for the minimalistic hooking library, and the whole point of it is that it's a very simple way to hook, but it is definitely not like undetected, and you're not going to hack Fortnite with this. But once again, this project is for learning. It's not for cheating against innocent random people. But anyway, let's head over to the release. And just like before, we're going to download the latest source code. Alright, so at this point, you should have minhook and ImGui and zip files in your downloads, and you should also have Visual Studio running. So let's go ahead and open that up. Okay, cool. So I've got my Visual Studio open. I'm going to go ahead and create a new project. I'm going to create an empty project specifically. If you don't have this on your recent project templates, then you're going to come over here, change this to C++, Windows, and empty project. You can just search for it over here. Now we need a place to store it. I'm just going to go ahead and store it on my desktop, and I'm going to call this epic menu. Depending on how fast your computer is, Visual Studio should open and you should see some sort of interface like this. Solution Explorer might be on the other side, like here or something, but I like having it on my left side. So let me put it back there. Now, the first thing I'm going to do is I am going to come and click this button, Show All Files button. That is going to show this our project as it is on your disk. So let's get started. We're going to go ahead and add a new folder, and we're going to call that source. Within the source folder, we're going to add a CPP file, and I'm going to call that DLL main.cpp, just like that. Within this, I'm going to add two folders, simply a core and an SDK. This is the very broad structure of our entire cheat that we're going to follow, and we're going to come back and fold this out a bit later, but for now, this is all we need, because we need to go and we need to mess with all of the project settings. So go ahead and right click on your project, specifically the project, not the solution. Right click on your project, come down here to properties, and you should have this window. Now in platform, please be very careful. Make sure you select x64. CS2 is 64-bit. CSGO was 32-bit, but now we are 64-bit people. So we're going to be using specifically 64-bit. And I recommend that you change this to all configurations. So every change you make now is going to apply to both debug and release builds. Anyway, so I'm going to go ahead and change solution dir, whatever, to build. So this is going to be the output directory. This is where you're going to find your DLL once you build. I'm then going to go ahead and copy that, and I'm going to paste that into the intermediate directory and just type intermediates and make sure to add the backslash. Now we're going to come over here to configuration type, and we're going to change from exe to dynamic library. That is, once again, we are making an internal, it's a module, it's a DLL, and this is very important. The next thing is I'm going to change my language standard over here to ISO C++20 because we're just cool like that, and go ahead and apply. Now I recommend you go ahead and copy this because we're going to come over here to VC++ directories. We're going to go over here to include directories. We're going to edit. We're going to create a new entry. We're going to paste solution.build, but we're going to replace this with external. And I forgot to add that in our project, but we'll come back to that now. So go ahead and click OK and apply. And the last thing we need to do is we need to come to the linker, go to system, and you see subsystem over here. We're changing that from console to Windows. This is going to allow us to use DLL main as opposed to int main, the standard entry point. We're going to use the Windows entry point. So go ahead and apply and OK. Now, as I mentioned, I forgot to show you to add this specific folder. We're going to make a folder called external. And within external, we're going to go ahead and add two files or folders. One is going to be ImGui, and the other is going to be minhook. Taking a look at our project on our disk now, we should see something like this. And we're going to take this time now to go ahead and add our ImGui and minhook source code. So I've got these two, I've got my downloads open and I've got my actual project open over here. Let me go into minhook, and as you can see here, you have a source and you have an include. Now, I don't particularly like that so much, so I'm going to come in over here into minhook, into source, and I'm going to drag everything from source into the minhook folder. Then I'm going to go back into include, and I'm going to drag the include into there. And that's all that we need for now. Next, in terms of ImGui, we're going to come back and we're going to go into our ImGui zip. And in this one, it's a little bit more complicated. We're going to go ahead and copy from the first .h file all the way to the last .h file, and we're going to drop those in there. Next thing we're going to do is come over here into backends, and we need to get four files from here. The first two files will be impl DirectX11.h and .cpp, drag those over. The next ones will be right at the bottom, and they'll be impl win32. So let's go ahead and add those as well. Now we can close out of all of that, and if we go ahead and refresh our project, you'll see now that we have access to all of this fun stuff. So let's right click on external and let's include in project. The last thing that I'm going to mention, this is completely optional, but I like to program with a Clang format. If you don't know what that is, it's a text file that kind of is going to auto format your code for you while you're typing it, just to keep it consistent and things like that. If you don't know what it is, just forget about it. But if you do know what it is and you want mine, I'm going to have a link in the description down below. Anyway, at this point, we should have our project going. Let's go ahead and write our entry point. To start off, we are going to write just a very simple entry point just to make sure that everything builds correctly, and we're going to make it pop up a window when we inject into CS2 saying that it was successful. This is just some simple boilerplate to include the Windows API as we do need it. So let's get started with our actual DLL main function. Okay, so at this point, we have a very basic entry point. Basically, as soon as we inject the DLL, this is the first function that is going to be called. That's why it's the entry point. If you're wondering, this is how every single DLL works. You can see MSD and documentation about it. And so far, this is pretty basic stuff. This applies to every internal that has ever been created. But what we need to do next is we need to make a thread, because you're not actually supposed to run your cheat within the DLL main entry point, because this gets called multiple times. So what we're going to do is we are going to go ahead and make a cheat thread that we can actually run our cheat within. So let's do that. Okay, so now that we have our actual function, our cheat thread that's going to get called, we need to actually create the thread within DLL main. Now, you could use standard thread for this, but since we've already done all of this, terrible Windows API code, let's just create it using the Windows API like so. Now, create thread takes a ton of parameters, but we can simplify it kind of to this. So I'm going to go null pointer, we're going to go 0, then we're going to pass in the function that we just created, so cheat thread, then we're going to pass in the instance, and then we are going to pass in 0 and null pointer. Okay, so just to explain what's going on here. When you call create thread on Windows, as you can see, this takes a function pointer called LP thread start routine. If we go to the definition of an LP thread start routine, you can see that it's actually a function that returns a D word and it takes an LP void parameter. So this is how in the old days before C++ and stuff, when people use C, if they wanted to pass information to a thread, they would pass it through this parameter over here, through the LP void. In this case, the only parameter that we want is the instance, because this is going to allow us to free the library and exit the thread right over here, just like that. So this is going to uninject the DLL, essentially, if you use the load library. Anyway, coming back to this, all we need to do here is see if thread is not equal to invalid handle value. In that case, we're just going to close the thread. So this is going to prevent any sort of memory leak or any problem like that. And why is it giving me a problem? Thread could be 0. Yeah, sometimes Visual Studio worries me. Anyway, at this point, we are going to go ahead and just add a message box over here. And we can pass in null pointer. So what a message box is it's like that dialog box that shows up, when you press X and it's like, are you sure you want to close? That's pretty much what that is. So all this should do is when we inject, it should show you a message box that shows you this fun stuff. Now let's go ahead and build, and I'm pretty sure we might have a problem with minhook. Let's see. Yes, so this is this is something we're going to have to fix quickly. So it's pretty simple. Try build and you should get this error over here. Double click on this, and where you see this include minhook, we are just going to remove that those forward slashes. So we're just going to include minhook like that and build. Okay, so once you fix that problem, you should see that now we have a successful build. And if you set up your project correctly and you go into it, you should see build, and then you should see the project name plus .dll, just like that. Now, from experience, I firmly believe that as you are making changes to your cheat, it's very important to constantly inject and uninject it just to make sure that you haven't royally screwed anything up. So we're going to do that now. We're just going to inject this DLL into CS2 and make sure that everything so far is working. Now, in order to actually test your cheat with load library injections, you're going to have to come over here to CS2, right click and go to properties and add the dash insecure option. This is going to disable VAC and it's going to allow you to inject anything you want into the game without getting banned, and you can use a load library injector. So make sure you've done that and then go ahead and play. All right, so my game is opened. It only took about 12 months, but we're finally here. I've gone ahead and I've added Xenos to my build directory. That's just what I'm going to use for testing, but you can obviously use any injector you want. I'll leave a link to Xenos in the description down below. So I'm going to go ahead and select my process. I'm going to go ahead and add my DLL and inject. And just like that, we ran into a problem. Okay, that was an epic fail. Let me go ahead and try this again. Okay, there we go. Now it worked. So the issue was I forgot to add return true over here after close handle. So go ahead and update your code. Make sure to add return true. And when you inject, you should get this sort of pop-up that says world. As we see here, we said world and hello over here with some sort of icon. So there we go. Alright, what's up party people? This is Cazz from the next day. Yesterday I was super tired, so I stopped recording, but you know what, we're back in action, we are back ready to code, and I realized after recording yesterday that I made a mistake over here. Basically, what we're doing here is a problem because we are putting the not operator on get async key state, which is not what we want to do, ironically enough. So to fix this, please just come back to this and add a bracket after the not operator and after the 1, and that is going to fix our problem. And I also realized that I didn't even explain what is happening over here. So essentially, the whole point of this is we're creating a thread so that we leave DLL main, and we're going to keep this thread alive. And how we do that is through this while loop. So basically what this is saying is while the end key is not pressed, keep sleeping, and that is going to keep our while loop alive. It's going to keep our thread alive so that when you do click the end key, it's going to jump over here to free library and exit thread, and it's going to uninject our cheat. Does that make sense? Hopefully it does. Okay, so with that out the way, it's time to move on to some memory utilities that we need to add. And we're going to do that over here in SDK. So let's go ahead and add 2 files. We're going to add, first of all, a source file, and we're going to call that memory utils.cpp. And then we're going to create another one called memoryutils.hpp. Now, I'm not necessarily a proponent of pasting. I don't really support it. But in this specific case, there is a lot of rubbish code that we have to basically type out. And I'm not going to lie, I don't feel like doing that. So what I've done is I'm going to leave 2 paste bins in the description down below. And all you have to do is go to them and you are going to copy all of the important stuff on there. So head over to the first one, memory utils, and hit raw. And then you're just going to copy all of this. And in your memoryutils.hpp, you can go ahead and paste. And just like that, we have the required for this part of the series, for this episode. This is all we need for now. And I'll come back and I'll explain it once you have all the code. So let's now go to memoryutils.cpp, and you'll find that link in the description as well. Let's go ahead and go to raw. This file is a little bit bigger, but we're going to go ahead and copy that. Head back to your memoryutils.cpp and paste. Cool, so now you've learned how to copy paste like a proper cheat developer, but regardless, let me go ahead and explain kind of what's happening here. So the first thing we have here is a class called padding, and most people, if you look around at other cheats, people are using macros for this, but since we're in 2025 and we have modern C++ features, I like to do this with an actual class that takes a compile time template size, and it creates a member that is that size. So essentially, if you create this class with a size, this member is going to be the size of what you gave it. Now that probably does not make any sense right now. That's completely fine because it will make more sense when we actually get to using it. The next utility that we have is virtual function get. What this does is it returns the function in a virtual method table at the index that you provide. Once again, I will probably be elaborating a lot more about this when we actually get to using it, but for now, you just take this at face value. You don't have to understand exactly what it's doing, but we'll get there. Next, we have find pattern. Now, this is just a simple signature scanning pattern scanner, and we use this to search for signatures to get data in the game that we can't otherwise get. This is a very essential function used in all CS2 internal cheat bases and externals as well. The final thing we have is resolve absolute RIP address, and that is quite a mouthful. But RIP does not mean rest in peace in this context, it means relative instruction pointer. And this comes to play when we are making x64 cheats as opposed to x86. So previously with CSGO, you would pretty much never use something like this, but now we do need to use this because sometimes with assembly, what can happen is we do have to be resolving all of these fancy ass addresses within the assembly code. And once again, I'm not going to explain this right now, but when we actually get to using this, I'm going to hop into IDA and I'm going to show you exactly kind of what's happening. Regardless, that makes up our memory utils. We are going to use these to essentially find patterns to make hooks. We're going to use this to get virtual functions for hooks. We're going to use this to basically pad structures so that we can access special member variables of those structures. And finally, with resolve absolute rip address, we're going to use that in conjunction with find patterns, because sometimes finding things can be a little bit more difficult than it seems. But anyway, that's that for our memory utils. Alright, ladies and gents, now it's time to start adding our interfaces. So head over to your SDK and create a new folder, and we're going to call that interfaces. Now, for this specific project, we only need 3 of them. It's pretty simple, but obviously later on in the series, we're going to be adding a lot more. But for now, we just need 3. So the first one is going to be CSGO input. Go ahead and create a header file called csgo input.hpp. After that, we're going to create another header file, and this one is going to be input system. Go ahead and create an input system.hpp. And the last one we need for this part in the series is going to be swap chain _DX11.hpp. So go ahead and add that one as well. In terms of CSGO input, we are just going to create a class and call it interface CSGO input, and it can be empty. Obviously, later on, we will probably be adding things to this, because this is the interface that controls the user command, which is used for a lot of movement related cheats. But for now, we just need a pointer to it. So we're just going to leave it empty, and it's going to be the same for the input system. So let's head over to input system. And we're going to do pretty much the same thing, interface input system, and just leave it empty. But the final one is slightly more complicated. We're going to start off by including the memory utils, and then we're going to go into creating our namespace. And yeah, looks like GitHub Copilot helped me out there, but we don't need this, so let's get rid of that. We're going to create class interface swap chain DX11. The first member we're actually going to have is a private. We're going to set the private access specifier, and we're going to use, from memory utils, we're going to use the padding thing that we created earlier, and we're going to pad for 0x170. After that, we're going to set the public access specifier, and then we're going to create a pointer to the IDXGI swap chain. Now, we don't have that defined right now, so let's go outside of here and let's forward declare that IDXGI swap chain, just like that. And down here, we are going to add the swap chain. Cool, so this is our first use of the padding structure, and just to kind of explain what this does, if I go ahead and hover over our class over here and I check out memory layout, you'll notice that all of this over here is the space that's being taken up by our padding. But if you come over here to offset 368, you'll see that there is our swap chain pointer. So that's essentially the point of the padding, is that it gives us the opportunity to basically fill out the class, and then at the address after this, we are going to be accessing our swap chain pointer. And obviously this is going to be used to basically hook our DirectX 11 rendering functions so that we can eventually render our menu. Alright, ladies and gentlemen, at this point, we pretty much have everything required of us for our SDK for this part of the tutorial series. So it's now time to move on to the core of our cheat and actually start implementing some stuff. We're going to begin with adding an interface manager. So I'm going to go to the core, I'm going to add a new file, and we're going to add interfaces.hpp, just like that. Next, we're going to add a source file, which is going to also be interfaces, except this time it'll be CPP. And inside of interfaces.hpp, we are going to begin. First step is to actually include the DirectX 11 header. And now we are going to go ahead and include all of the current interfaces that we have. Once you've added all of your interfaces, we can start with a namespace that we're going to call interfaces. Let me just make it a bit bigger so that it's easier for you guys to see. And inside of here, we're going to have 2 methods. First of all, we're going to have void create. And then we're going to have void destroy. And now we can go ahead and list our interfaces. Basically, we want to hold global pointers to these interfaces so that our entire cheat can access them when we need them. Obviously, right now, because we're just making a menu, it's not going to be super important, but you will see how important it will get later on when we are actually dealing with entities and we need to access things from the interfaces. It's very important that any variable that you declare inside of this header file is inline. Otherwise, you are going to get a bunch of unresolved external issues, or actually you're going to get issues that say that X has already been defined in this place and that place, and let's just avoid that. Now, the other stuff we need to add is actually DirectX 11 specific things. This is going to be helping us out with rendering and specifically for our menu. So these aren't typical CS2 interfaces like you'll see up here, but they are still required and we are going to have them globally accessible to the rest of our program. So once you have all of this typed out and you're sorted out, head over to your CPP file and let's start actually implementing it. Your first step, of course, is to actually include the header file. So let's include interfaces.hpp. Next, we are going to declare the namespace. This is so that every definition that we give to our functions is not going to require the interfaces prefix. Now, for our interface manager, there are a lot of ways to go about this, but because we are on the first episode and interfaces aren't actually that important just yet, I'm going to give you a very simple version, but we will be upgrading it much later down the line. To begin, we can start adding our create and destroy methods. We can just leave them empty for now, and I'd just like to explain kind of what's going to happen here. As you might have assumed, we're going to call create to set up all our interfaces, and we're going to call destroy to free anything that we need to free. Now, before we do anything else, we are going to need to include two other things, and that's going to be standard exception and format. Next, we're going to go ahead and create our create interface function. So follow along. Okay, so AI has kind of handled this for me. Let's take a look at what we have over here. This looks correct, yeah. So we're going to get a handle to our module, the module name that you supply, and if that fails, we're going to throw an error, an actual and an exception. Next, we're going to give the type of the function that we're going to get from getProcAddress, which is going to be create interface, and then we're going to create it and return it. Okay, that looks good. Now, if this doesn't make sense to you, I can understand why, and that's why I have actually opened up IDA Pro over here. I've opened up the input system.dll, and I'm going to show you kind of how this works. If we head over here to the exports tab, you will see that there is this beautiful function over here called create interface that is exported. Any function that is exported can be accessed through this procedure over here, getProcAddress, which literally means get procedure address. And if you'll notice, we are passing in create interface. So basically, we are asking the operating system to give us the address of the function called create interface in the module, whatever we pass into it. And in this case, we are going to be passing an input system just to get a pointer to the actual interface. Once we have all of that going, then we actually call the function, because remember, we now got the address of the function and we call it. And here we will have the interface pointer that we can then return. So in practice, that's going to look something like this. We're going to call capture interface. We're going to pass in the type, right? Obviously, we are capturing a interface input system class, and we're going to give the module, which is input system.dll, and then you have to give a version string. Now, once again, this is the most basic create interface that you can have, and later on in the series, we are going to make an advanced one where you don't actually have to give the version string. It'll automatically figure it out for you, but for now, we need the version string. And just in case in the future that this breaks, what you're going to do is you're going to open up IDA Pro, you're going to go to View, Open Subviews, and you're going to look for strings, and then you are going to search for input system version, and you'll see that what comes up is input system version 001, which means that that is the most correct version. So theoretically, this should work. We're going to leave this empty for now, and we're just going to make sure that it is working before we move on to getting the other two interfaces, because these two are not traditional interfaces that can be captured from create interface, or capture interfaces I've called it. Rather, we're going to have to signature scan for those. We're going to use that pattern scan utility that I mentioned earlier. But for now, it's a good idea to actually test that this works. So to do that, we're going to head back to DLL main, and over here, we're going to go ahead and include our new interfaces file, include core interfaces. And now what we're going to do is, because it throws an exception, we're going to use a try catch block. And once again, AI is ahead of me over here. We do need to include standard except though. That's very important. And there we go. What this is going to do is if something does go wrong, it is going to throw an exception and we're going to see a message box, and then it's going to uninject our cheat with the exit code of 1, because that is the parameter over here, exit code, and 1 is an error, whereas 0 means everything was successful. So I think it's just about time to go ahead and build this, and let's inject it and let's make sure that everything does go as planned. Alright guys, so I've got the game open. Just before we inject, what you should expect to see is that very first message box that happens no matter what, and then hopefully we see no message box, because that means it was successful. So let's go ahead and inject. I should probably select the correct process first. Let's try that again, and we get our desired message box, and we get nothing else. Alright, cool. So it works. Now it's time to move on and add the rest of our interfaces. Alright, ladies and gentlemen, obviously at this point we have a single interface working, but we still have a bunch more to get, just in more unconventional ways. But before we move on to that, I kind of want to modify our cheat thread over here, because this message box is starting to piss me off. So the first thing I'm going to do is I've removed that top message box and I've put it down here, converted it to message box A instead of using the actual macro, and I've just updated it to be cheat is exiting and the title will be info, just showing some information. The other thing that I want to do is before that, I want to just in case we forget one day in the future, I want to add interfaces destroy over here. Next, just like we did after the while loop, inside of our catch over here, we also do want to destroy interfaces just in case things were created, but it failed at some other point. So let's go ahead and call interfaces destroy just like that. Okay, so now it's time for us to move back to interfaces and continue with this. But I did realize that I forgot something over here. We need to add something, so follow along. Please come back and remember to add an hwind, which is a handle to a window. That's going to be the actual CS2 window that we're going to get from all of our other stuff. You'll see it's going to be a little bit complicated and convoluted to follow. But to begin with, we're going to start simply and just get CSGO input. So let's do that. Going back to interfaces.cpp, right above our input system, I'm going to create a new scope. You can do that by adding just empty brackets. And we're going to start by actually pattern scanning for the CSGO input pointer first. And that is going to look something like this. Remember, we don't have to actually check that address is valid because in find pattern, if it doesn't find the address, then it is going to throw an error that will be caught in our DLL main, and it will show a message box. So you don't need to worry about that. Returning back to interfaces, now what we need to do is actually use that utility, this one right over here, resolve absolute rip address. And yeah, it's actually already ahead of me, except we're not setting that to address. We're going to set that to CSGO input, the actual pointer itself. Now we obviously have an error here because CSGO input is of a different type to resolve absolute rip address. So we do need to wrap this into a reinterpret cazz. So let's do that. And just like that, that pretty much finalizes our getting CSGO input. Now, I would like to take some time to actually explain what this resolve absolute rip address does. First of all, let's consider its parameters. It takes an instruction pointer, which is the pointer to the instruction that we want to do the work on. Next, it takes an offset to displacement. And finally, it takes an instruction size. So I'm going to go ahead and hop into IDA, and I'm going to show you where this pattern takes us. And then I'm going to tell you exactly how in the future you can actually use this utility for yourself. So I'm over here in IDA Pro. I've opened up client.dll, and after pattern scanning for that address, it takes me right over here to this line. Now, obviously, the CSGO input pointer that we want is sitting over here in the keyword, but pay attention that there is a CS over here in front of it. That means that we have to use this specific function, resolve absolute rip address. Now, what do these exactly mean? The first parameter over here is actually referring to the size of the assembly instruction. So it's clearly a mov. And if we take a look at the bytes, that means that the first 3 bytes out of all of these bytes is actually just the mov instruction. These 4 bytes over here are actually referring to the keyword itself. But this is where it becomes tricky because it's actually referring to an address of where the keyword is, and that is the whole point of this function. So how does it work? 3 is referring to the size of mov, and 7 is referring to the size of all the bytes in this instruction, right? So if we go ahead and count 1, 2, 3, 4, 5, 6, 7, it's 7 bytes. So that's how it works. Hope that makes sense. If it doesn't, go and ask the wizards who are sitting in the ChatGPT box. Cool. Anyway, right now I recommend that you pause the video, go ahead and compile, and make sure that when you inject, there is no box popping up, because if there's a box popping up, then you're going to run into problems. Cool. Now, another thing that I forgot is we want to quickly come back to swap chain DX11, and in your code, it should actually say class over here, but I want you to change it to say struct. That is a mistake that I made earlier in the video. So go ahead and change your, which should say class, change it to struct. So I hope you've injected and I hope nothing went wrong. I've already done this. I actually recorded this segment earlier and none of the audio was working, so I'm redoing it. I know that it works in my case right now, but for you, please make sure it works. And oh yeah, another thing I wanted to mention. If this signature is, of course, outdated, which is very possible, open up client.dll in IDA Pro and search for the string CSGO input. The pointer that you're looking for will literally be right over here, just above it, and then you can go ahead and create your new signature just like that. Cool. So that is our CSGO input signature done. Now we need to get the swap chain, and using the swap chain, we're going to get all of this stuff. And after that, we're going to move on to hooking and a little bit more fun stuff. Now, this is probably the most complex part of the video. It's just going to be a little bit difficult to follow because it is going to be a lot of code that seemingly doesn't make sense, but eventually it will make sense, and we're doing it for a good reason. So as I said, because it's going to be quite a bit of code, I suggest that we make our own little helper function. I've just created an empty static function that is called create D3D11 resources. And within here, we are going to go ahead and do all of that fun work. So let's get started. First of all, it's going to look very similar to this. So I don't actually recommend copy and pasting code once again, but I'm going to go ahead and copy this and paste it in here. We're going to rename CSGO input to actually be swapchain DX11 like this. Then we are, of course, are going to be modifying the actual class to be the swapchain DX11 interface. The next thing we're going to do is these pointers actually change. So instead of casting to a double pointer and dereferencing once, it's actually casting to a triple pointer and dereferencing twice. Don't ask me about that. Go figure that out for yourself. And then, of course, we need to update the actual error check over here to be swapchain DX11. And then, might as well also update the actual error code just like that. Now, the last thing we need to update, of course, is going to be the signature. First of all, this is not located in client anymore. This is located in render system dx11.dll. And the signature is a little bit more simple. I'm going to go ahead and copy this quickly. So just to confirm again, I'm going to hop into IDA and show you exactly what's going on once again. All right, I'm back in IDA. This time I'm in render system DX11 and I've pattern scanned and it's taken me right here to this line. Once again, if you count this, that is 7. That is why we are using the parameter of 7. And once again, it's a MOV. So once again, we are going to be using the parameter of 3. This in specific is the actual keyword that we're looking for. Upon, second thought, this is going to be a little bit more difficult to find one day if it is actually outdated. But as you can see, there are plenty of strings over here that you can go ahead and search for to find this exact function. And then I recommend you go and look and actually match up the exact bytes. Take a look at this and try and match it up and you will find it eventually. So with that out the way, let's continue. Once again, this is going to be a little bit complicated, but try your best to follow along. First of all, we're going to try and extract the swapchain, the actual swapchain pointer out of our interface, and that's going to look something like this. Just like that. But before we do that, because this is actually a dereference, we do want to really make sure that that is not null pointer. So let's go ahead and do that. There we go. And if this error ever does happen, that means that the offset that we have inside of here, let me show you quickly. That means that this padding needs to change. So I'm going to update the error message to say that. At this point, we now actually have a pointer to the swap chain. Our next step is to get the D3D11 device. Once again, AI is coming in clutch over here. I'm just going to hit tab and that's going to go ahead and do that for me. Obviously, we are using the swap chain that we just extracted from our interface, which we found from the signature. And we're going to call get device on it. We're making sure it didn't fail. And even if it, didn't fail, we still do want to make sure that the 3D11 device is not null because we will still run into problems. Once we have the device, we can use it to get the immediate context, just like this over here. So get immediate context, and we are going to be populating D3D11 device context this time. And once again, after that, we do want to make sure that device context is not null pointer. AI is running ahead of me over here, so let me just remove that. Now, in terms of our interfaces, we have the device, obviously we have the swap chain, we have the device context, but we do not have the render target view. So let's go ahead and get that. We're going to go ahead and create a back buffer, set it to null. We're going to use the swap chain to call get buffer, and that's going to populate the back buffer. We're then going to make sure that it's still not null, because if it is, we ran into an issue, obviously. And then we're going to use the device to call create render target view, passing in our back buffer, and that is finally going to populate our D3D11 render target view. And if something goes wrong, we of course do want to release the back buffer, but also anyway, after all of that, we are going to call back buffer release because we have no use for it any longer. Then after that, we are going to make sure that the render target view is not null pointer once again. Now, the last thing we need to do is actually just get our hwind over here, which is relatively simple. Once again, AI is ahead of me over here. So how that works is we're going to open another scope. That's not necessary, but I like to do it like that. Then we are going to go ahead and create a swap chain description. We're going to use the swap chain to get the description. And why are we doing that? Well, that's because this structure, swap chain description, has access to the hwind that the swap chain belongs to. So we're going to go ahead and grab the window handle just like that. Now, after all of that, once again, probably quite difficult to follow, but I am going to just run through it one more time. So we created a new function called static void create D3D11 resources. We pattern scanned for the address. Remember, your address could be outdated, but currently, your signature could be outdated, but currently this is the correct one. Then we set our swap chain. Remember to make sure that all of your pointers are correct, and we resolved the absolute address. We then make sure it was correct. Then we extracted the swap chain just like this. Then we got the device by calling getDevice. Next, we made sure that that wasn't null. Then we used the device to get the immediate context. Once again, made sure that the context was not null. Then we create the render target view by creating a back buffer, calling getBuffer, and then making sure that's not null, so on and so forth. We release it, and then eventually we make sure that the render target view is not a problem. And finally, we get to this point over here where we get the description from the swap chain. We use the description to get the handle to the window, and then once again we make sure that that is not null. After all of that, I really hope you managed to follow. All we have to do is scroll down to our create function and call create D3D11 resources, just like that. We're almost done. We are so close, but we do need to add this destroy method. Why? Well, that's because a lot of these functions over here, for example, when we call D3D11 device get immediate context, it's actually increasing the reference counter internally for the actual COM object or whatever it's called of the device context, which means that if we don't then release it, this device context will probably never be released properly, or we can just run into bad errors. So, this is kind of how managing memory manually works. Whenever we are using something, we need to remember to destroy it. So let's come down here to destroy. And once again, AI coming in super clutch. Thank you, GitHub Copilot. We're going to make sure it's not null. We're going to release it, set it to null, so on and so forth. And then we're just going to set everything else that we have over here to null. So yeah, quite a mouthful, quite a lot of code, but now it is the fun part, or maybe the not so fun part, where we are going to go ahead and build this. No errors, that's always great to see. I'm now going to launch my CS2 and we're going to inject and see how that goes. Okay, ladies and gentlemen, I'm back in the game. Once again, took like 9 months to open, but remember, the goal of this is we don't want to see anything pop up until we uninject. Okay, obviously a crash is bad, and obviously a pop-up will be bad. So let's go ahead, fingers crossed, inject, boom, nothing happened. That's very good. And it could be bad because maybe there was a failure, but let's go ahead and uninject by hitting end. And just like that, we got info, cheat is exiting. Okay, that is good news. Alright, what's up guys? This is Cazz from about 2 weeks later. Unfortunately, I got really busy, so I didn't get around to finishing the video, but we're back in action, we're back ready to code, so let's do it. At the moment, you have a DLL that can be injected, you set up your interfaces, and it should give you a message box when you uninject. At this point, we're all sorted in that regard. The next step is to actually start with our hooks. So the first step there is to go over to your core folder, and we're going to add 2 new files. The first file will of course be a hooks header, so hooks.hpp. And the next file will be a source file, so hooks.cpp. Great, so once you have those, let's go to the hooks.hpp and let's create our hooks namespace. And we are of course also going to have a create and a destroy method that's going to set up our hooks. And then we're going to remove all our hooks over here when we uninject. So that way you can test your cheat by injecting and uninjecting, hooking and unhooking. Alright, so once you have your create and your destroy methods, we're going to come over here to the top and we're just going to include one file, and that's going to be our interfaces.hpp file. That already contains all the definitions that we are going to need for the rest of this header file. Now, we are going to be hooking 3 separate functions, 3 rendering related functions, and the reason for that is the first one is literally for rendering the menu. But the other 2 we're going to need because every time you resize the window or you tab out and things like that, if you don't hook these functions and implement the fixes that I'm going to give you, then your game is going to freak out and it's going to freeze or it might crash. So I'm going to try give you the sort of the most complete menu possible, yeah, so just follow along. If it doesn't make sense, that's okay, because I will explain when we do actually get to the functions and sort of what they're doing. So yeah, let's do it. So the first function we're going to be hooking is present, right? So this is from the DirectX11. This is a standard DirectX11 function, and it's basically presenting what's going to be on the back buffer to now on the screen. So yeah, we'll get to that once again. It'll make more sense when we actually get to it, but this is the main function where we're going to render our menu. The next function we have is resize buffers. This is called when the menu is resized, and we need to update some things inside of here, just so that, as I said earlier, our game doesn't crash. The final function we're going to be hooking is going to be create swap chains, so let me add that. And there we go. That's what the create swap chain looks like. The reason we're doing this is we're basically just setting a signature for the function, and that's going to allow us to create this variable over here, which is a function pointer, which is going to hold the original function. So this is going to allow us to essentially call the original function whenever we want, cross the cheat, because that will come in handy a bit later. But for the most part, this is just to call the original function actually from the hooked function. So cool. That pretty much sums it up for our hooks.hpp file. So we have these signatures, we have create destroy, and now it's time to go and implement it all. So go into your hooks.cpp file, and first step is to obviously include the hooks.hpp file. Next, we can set out our namespace once again, so namespace hooks. And once you have that, we're going to come over here to the top and we're going to start including something. So the first thing that we are going to include is going to be minhook. If you set up your project correctly, as I did in the beginning of the video, you should be able to access minhook as a library like this, minhook, if I could spell it correctly, and then you can go ahead and include minhook.h. Now after that, we are going to include ImGui just for now. So once again, ImGui should be accessible through the sort of library includes if you set up your project correctly. So just go ahead and follow along over here. Alright, what's up Drama-Alert Nation? I am your host Cazz, and funny story. So I actually went on to record for another 40 minutes after the part you just saw, and it turns out that my audio cut out exactly there. So that's always fun. I always love when that happens. But anyway, we're back, and this video is a bit cursed. I see my mic's clipping. Let me just turn that down. Okay, so it's time to code and get this done. So let's go ahead and remove this spelling error well, not spelling error, but let's remove that since I noticed that in the recording. And we are going to need to include one other thing, which is going to be standard except, because we are going to be throwing some runtime errors. Now it's time to move on to actually, defining our hooks. So outside of the namespace, we actually need to go ahead and write the definitions for our 3 hooked functions. So effectively, this is going to be where we can access or we can place code that the game is going to run, right? So just go ahead and follow along. Probably won't make too much sense until I explain it, but I think that's pretty much how most of this video has gone. So let's do it. Alright, so for our first hook, we are just going to implement a basic hook present, and this is, all it's going to do is it's going to return by calling the original function. So effectively, we're not changing anything, and we're just going to do this just to test that our hooks are working before we obviously go any further. And in this case, the only thing to really note is that we are going to pass in this cached swap chain. Technically, you could also pass in the actual swap chain pointer that is passed by the function that's calling it, but ultimately, in this case, and you'll see why later, we do want to use this sort of cached swap chain pointer that is held on to by the game. Yeah, so that's all we need for the hook present for now. Let's move on to the resize buffers hook. So when it comes to our resize buffers hook, it is actually a little bit different to present. First of all, we are actually going to call the resize buffers original function first, right? So if you don't understand what that means, essentially over here, we will be doing things before the original function is called, but in resize buffers, we're actually going to be doing things after the original function was called. And to do that, we essentially call the original function, store the result, do our work, and then go ahead and return the result. The only thing to really note over here is that we are going to be passing in just the regular swap chain that is passed through the function. So nothing really to worry about there. It's probably going to be quite annoying to type out, but just go ahead and do that. So the final hook that we need to implement is actually just going to be our create swap chain. And once again, it's going to follow the same format, hresult, standard call, hook prefix, and yeah, so let's just do it. So when it comes to our hook create swap chain, it is going to be pretty much the same as our hook present, except we are just going to pass in the normal DXGI factory. We're not going to be doing any interfaces, funky stuff. And once again, we're going to be doing work before we call the original function. So just as a note here, I'm going to add do stuff here. You obviously don't need to add that, but this is just for my mental note keeping. Anyway, so once you have all of that, it's time to actually move on to create and destroy, right? So placing our hooks and removing our hooks so that we can easily inject and uninject our code. So let's go ahead and do that. All right, so go ahead and scroll down a little bit, and we're going to get started by implementing our void create and our void destroy. Now, AI pretty much has done most of the work for me over here, so I'm going to go ahead and accept that and just remove all of the unnecessary things because we don't have to vibe code everything these days. So let's go ahead and remove just these parts right over here. Okay, and then I'm going to add one thing down here before I explain exactly what's going on. Alright, so just to begin, your void create and void destroy functions should look something like this. Void Destroy is completely finished. We will not be touching this anymore for quite a while. If even, I don't think we will be touching it at all for the rest of the video. But Create is going to need a little bit more work because we do actually need to place our hooks. So just to explain what's going on here, we are calling mhinitialize, which is going to initialize the minhook library, and we're just making sure that everything goes well. And if something goes wrong, we're going to throw an error just so that we do understand when things do go wrong, right? Now, next, inside of here, we are going to go ahead and place all of our hooks in between these two function calls. And right at the end, we are going to call mhenable hook, all hooks, which is going to go ahead and enable all the hooks so that we essentially have hooked these three functions over here that we just wrote out. Alright gamers, so now we have reached the point where we actually want to place our hooks, and it's actually not too complicated, so just go ahead and follow along. The first two hooks that we're going to place are pretty much the same, so I'm going to do them in one shot and then I'll come back and explain what's going on there. And then hooking create swap chain is a little bit more difficult, but nothing crazy. You'll still survive, don't worry, so let's just do it. Alright, so for the first hook that we are going to be creating, it is going to be our present. And this is what that looks like. Sorry, not present, present. Okay, we're going to call mhCreateHook, and we're going to do that inside of an if statement so that we can make sure that it is okay. If it isn't okay, we are going to go ahead and throw an error that says failed to create present hook. Now, in terms of the hook itself, it's pretty simple, looks complicated, but actually isn't that bad. By the way, it is raining extremely hard outside, so I apologize if there's some crazy background noise. But to explain this, we are calling SDK virtual function get, which is going to get a virtual function from a given virtual method table. And in this case, we are passing in the swap chain virtual method table. If you hover over this and you check it out, you have IDXGI swap chain. And if you come over here to our top two hooks, they both take a this pointer that is going to be the swap chain, right? So that means that we are basically hooking from this very virtual method table, right? Or that class pointer. So what we are doing is we are getting the method at 8, which just happens to be, or at index 8, which actually happens to be the present function itself. And we are hooking that and we are placing the old function into our original present variable. And that is going to allow us to once again go ahead and call the original function. So I kind of hope that makes sense. If it doesn't, go ask ChatGPT because that guy's pretty cool. Now for the next one, it's actually the same thing. So we're pretty much going to go ahead and copy this and I'm going to go ahead and paste it. And I don't recommend doing this normally, but right now I don't care. And we just need to change a couple values. So we're going to change from 8 to 13. We can keep the exact same swap chain pointer. Now instead of hooks present, right, because we already hooked that, we're going to change this to hook underscore resize buffers. So let's get that going like that. And then of course, instead of the original present, we are going to have original underscore resize buffers. Just like that. And it's probably a good idea to go ahead and update the actual, error message, or else you might get confused when things go wrong. So let's do that. This is going to be resize buffers. Like that. Cool. Now, unfortunately, hooking the next function is a little bit more complicated, but it is definitely not rocket science. So go ahead and follow along. Now, before I do that, let me just explain something. As I mentioned, these two are taking an IDGX or whatever this is, IDXGI swap chain. But as you can see, this one is taking an IDXGI factory, which means that we need to go and find how to get the factory, the IDXGI factory pointer so that we can hook methods from it. So to do that, it's a little bit of jumping through hoops, you know, like a dog at a show. We've got to do about 3 or 4 steps to eventually get to that and then place our hook. So go ahead and follow along. I'm going to take this step by step and hopefully it does end up making sense. So for our first step, we are going to get the DXGI device, and we're going to get that by accessing our DirectX11 device and calling query interface on it. And obviously if things go wrong, and how do we test that? Well, we use the failed macro. If things go wrong, we are going to print out this error message. In terms of our next step, we are going to be getting the DXGI adapter. How do we do that? Well, we access the thing that we just got, which is the device, and we are going to call getAdapter on it. And that is going to give us the adapter, obviously. But one thing to keep in note, or to keep in mind, is that if something goes wrong, we need to release these resources. So you're going to see that this is going to start piling up a little bit later. But for now, make sure to remember to pretty much release the device if things go wrong. Otherwise, you risk having some memory leaks along the way when injecting and uninjecting multiple times without restarting the game. So the final step is to get the DXGI factory, which, if you remember, this is exactly what we want. We want an ID XGI factory pointer, and we get that by accessing the adapter. We're going to call getParent and passing in all of this rubbish over here. And if something goes wrong, once again, we are going to release the 2 previous resources that we had. Now we have everything required to go ahead and place our hook. So let's do that. So this hook is going to look something like this. We're going to be accessing index 10 of the DXGI factory. We can keep it as a void pointer. Just remember to change this to hook create swap chain and make sure the original is create swap chain as well. If something goes wrong by checking if it's not MH OK, then we are going to release all of these previous resources that we used. And actually, you should go ahead and copy this and paste this down here as well, because we need to release them anyway, because we don't need them anymore, right? We've placed our hook. We don't need it anymore. If we ever do need the DXGI factory again, we can get it from over here when it gets called. So that's not a problem. And yeah, that actually almost sums up everything for the basic implementation of our hooks. The only thing we actually have left to do is to go to our DLL main, and remember, we actually need to call hooks create. Now, I already have this here because I've recorded this segment about 10 times over the past 3 hours for various different reasons, mainly audio related. So let me just make sure my audio is working, and it is. Okay. So yeah, go to your DLL main and make sure to place hooks create and hooks destroy and hooks destroy. Otherwise, nothing is going to happen because you're literally not even calling the code. So at this point, you should actually have fully working hooks. And the way we're going to test that, something that I've been stressing throughout this entire video, is that every time we make a change, we're going to build and we are going to inject into CS2. But I'm going to show you something extra. I'm going to show you how to tell that this exact function is being called from the game to really verify that our hook is absolutely working. So I'll catch you in a second when my game is open. By the way, you do want to go ahead and build the application or the DLL, otherwise you aren't going to get very far. So I've built, and as you can see, one succeeded. We are very, very happy about that. So yeah, I'll catch you guys when I'm in game. Okay, so I've got my game launched and I've got Xenos over here ready to inject. But first I have to show you how debugging works. So make sure that you did build your game in debug mode like that, and come over here to the top and set a breakpoint right over here on the present hook, right? So what this is going to do is it's going to freeze the game if this function does ever get called. And if it does get called, that is a very good thing, because that means that the game is trying to call present, but instead it is calling our function, which means that we can go ahead and place our menu in here. Now these two we're not going to test right now. They should be working, and if they aren't working, that's very unlucky. Go and watch the video again. But theoretically, these will only change if you change your window size, which can be quite annoying. So as I say, we're not going to test that right now. For now, we're just going to focus on present, place a breakpoint over here, go to debug, and go ahead and click attach to process. Now you can, mess around in here, and you can go ahead and find cs2.exe and click attach. Please note that you do have to please note that you do have to launch the game in insecure mode for this to work, but you should be doing that anyway, because you're not actually cheating online, because you're a good boy. Anyway, let's go and open up Xenos. As you can see now, we have this different UI with this red stuff going on, and if we inject the game, or if we inject our cheat into the game, we should see this breakpoint get hit. Right now it says the breakpoint will not currently be hit, no symbols have been loaded, blah blah blah. That's because we haven't injected yet. So let's inject, and there we go. As you can see, the game has frozen. We can't really click on it or touch it. But if we come over here to our Visual Studio, you will see that this breakpoint has been hit on hook present, which is a very, very good thing. As you can see over here, you can see exactly what was passed through it. And let's continue. And we have a crash, which is not that's not good. Okay, so I'm not sure if this is the problem that I'm facing, but this is definitely something that's wrong. I need to come down here, and I realized that I left out all of these address of operators. So in front of all of the original functions that you're going to be storing, you do need to go ahead and place the address of after this void double pointer cast. So go down to every MH create hook that you have and make sure to place the address of operator, which is the ampersand symbol, in front of it. So that means our swap chain, that means our present, that means our resize buffers, and as well as scrolling all the way down here to our original create swap chain as well. So let's go ahead and do that. And now theoretically this should work. If it doesn't, then I will come back to you, but let's go ahead and check this out. So I'm not trying to dump the process. I'm going to go ahead and reattach to CS2. First of all, I need a build, obviously. I need a rebuild. There we go. Now let's go ahead and reattach to CS2. And now let me go ahead and find the process again and inject. Okay, Windows Defender decided to cock block me there. Okay, so finally my Windows Defender is off. That took forever. Let me go ahead and inject. What is that? Okay, there we go. So I just injected and nothing popped up, which is a good sign, and it didn't crash. So let me go ahead. You can do this the opposite way. So I've already injected. Now I'm going to go ahead and reattach the CS2, and there we go. Okay, we hit the breakpoint again, and this time swap chain is not null. So yeah, that was the problem. Make sure to go back through your code, and as you can see here, if I keep continuing, you can see that we are getting different flags and different frame calls essentially. So yeah, make sure to go back through your code and make sure to go ahead and fix that problem. That is my bad. Make sure to add the ampersand symbol in front of every one of your original hooks so that you do not run into the same error that I ran into. But if you do run into other errors, the debugger will be extremely helpful. Place breakpoints and step through your code. Anyway, at this point, it is just about time to move on to the menu, the last segment of the video where we are actually going to implement our ImGui menu. So let's do that. All right, ladies and gentlemen, you've made it this far, and now it is time to actually move on to adding our menu into the project, right? But before we do that, we do actually have one thing that I did forget a long time ago in the beginning of the video that we do need to go and change. So let's head over to our interfaces, and we need to add two functions over here. We're going to go ahead and add create render target and destroy render target. Now, this is going to be pretty easy because you actually have all the code already. It's just sort of not in the right format. By placing these functions here, we'll be able to access them anywhere else in the cheat. And that's exactly why we're doing this. It's because we need to access these for our menu when we resize the menu. So let's head over into the interfaces.cpp implementation, and let's scroll down all the way to the bottom. And let's go ahead and just define these functions empty. Okay, so now that I have create render target and destroy render target as just empty definitions, the AI has actually picked up what I want to do with this second one. So I'm going to go ahead and accept that. Basically, all that destroy render target is going to do is it's going to check if it's not null pointer. If it is, it's going to release it, and then it's going to set it back to null pointer, right? And now that we have that implemented, we can come over here to the normal destroy method, and we can replace this with destroy render target just like that. Okay, that's that done for now. Now create render target will be a little bit more complicated. So let's scroll up all the way here to this method, the create D3D11 resources. Scroll down and find this scope over here, this one. The one that starts with getting the back buffer, the texture 2D back buffer, and this is responsible for creating the render target. What we're going to do is we are going to come in here and we're going to copy this, and then we can remove this. And let's scroll down to the bottom and paste this into create render target. So we're basically just moving the code to a better place. Now, what we need to change in here is, first of all, swap chain is not accessible like this in this area. So we need to actually get the swap chain from swap chain underscore DX11, and then use the pointer, the arrow, and then, okay, I don't know why it just screwed me over like that, but it should look something like this. There we go. So you're going to use swap chain DX11 to get the swap chain to then get the buffer. And why are you still complaining? Oh, I mistyped that. It's supposed to be get buffer. There we go. Okay, now the other thing that we need to change is just because we are going to call this in a context where things could be null, we definitely do want to make sure that the things that we require to actually set up the render target are not null. And that's going to look something like this. We're just going to check if D3D11 device is null, or if swap chain DX11 is null, or if this dereferenced is null. And if it is, then we are going to throw an error because we are going to crash anyway, so might as well throw an exception. Now, the only thing we need to do with that is we need to scroll up to where we were initially creating the render target, which is here in create D3D11 resources. You can scroll right to the bottom of that function, and we can just add it right over here, create render target. And now we can actually move on to making our menu. Okay, so now it is time to actually go ahead and add the files that we need for creating our menu. So that's going to be pretty simple. It's just going to be 3 files, so follow along. The first file is going to be a menu.hpp file, just like that. The second file is going to be, of course, the menu.cpp file. So let's add that. And the last thing that we're going to need is just a globals file. I mean, you can name this whatever you want, but I'm just going to go with globals. And what that means is it's basically going to be shared state across the cheat so we can check different things and do different things at different times. That'll make more sense when we do get to it. But for now, globals.hpp. Let's go ahead and start in globals because it's very, very simple. We're going to create a namespace. We don't need to include anything. I'm going to call it globals without caps, like that. And then we can go ahead and add an inline bool called menu opened. Yeah, that seems pretty good. Now, obviously later on in the cheat series, like once we've added way more things, we're going to have our features in here, like inline bool is ESP on, is aimbot on, etc. like that. For now, all that it's going to be is simply just menu opened. So pretty important. We are going to be using that just now. This is just so that we can obviously toggle our menu. But for now, this is all that'll be, and you're done with globals. You won't need to touch that for the remainder of the video, I think. Now we can move on to our menu.hpp. So this is going to be sort of the public interface of our menu, right? The functions we need to expose to the cheat to create, destroy, and render our menu. And I've already given it away. That's exactly what we're going to do. Once again, you don't need to actually include anything here, but we're going to make a namespace called menu, and AI is clearly listening to my microphone because that's what we want. We want create, destroy, and render. Now, with that done, we can move into our menu.cpp where we are going to be working for a little bit. So let's get started by including all of the things that we are going to need to include, all the header files. The first one, of course, is going to be the menu.hpp file, which is because this is the corresponding file to that. Now we are going to want to include pretty much the rest of our core. So let's just do that in alphabetical order, in alphabetical order because, some people like me have autism. So that's going to be globals first. Then it's going to be hooks. And finally, we're going to include the interfaces. And the only thing that we actually need to include over here now is, I am hallucinating. Then we need to include probably the most important thing in here, which is going to be ImGui itself, like that. So yes, AI, keep it coming. There we go. Okay, we're going to include these three files, the ImGui header file, the DirectX11 implementation file, and the Win32 implementation file. And now the final thing that we're going to include is standard except, and that is so that we can throw errors or throw runtime errors when things are incorrect. So now we can get started by creating our namespace menu. Once again, the AI is really going crazy over here. So I'll take that, but let's just go ahead and delete that. We just leave it empty for now. Then we can also go ahead and create our void destroy. And finally, let's create the void render. So now we have our create, destroy, and render. They're empty. We haven't started with them yet, but of course we will be getting into those very, very soon. Now, step one for creating our menu is actually going to be a WinProc hook. And when I say hook, I do mean hook, but it's not a hook in the sense that you would be used to. It's not a hook like you'd find in hooks.hpp or hooks.cpp. It's actually sort of built into Windows, and you'll see what I mean now. But it does still function like a normal hook, but it isn't done like this. But the point I'm trying to make is that we need this because that is the function that gets called when event messages are sent to the window. And that is going to allow us to send essentially input to ImGui, so it can understand when you are clicking a checkbox or clicking a menu button and things like that. So doing that is actually pretty simple. You're going to see right now. So let's do it. All right, so we're going to create a static variable of type WinProc, and we're going to call it original WinProc. Let me be consistent over here. There we go. And we can just set it to a null pointer for now. Now, the next thing we need to do is basically define the WinProc that is going to be our hook. So what the game is going to call instead of what it thinks it's calling, kind of like last time. So let's go ahead and get started with that. So this is what a WinProc looks like. This is actually just the standard definition of one. And if you've ever tried to use the Windows API and make a window or anything like that, then you've definitely ran into a WinProc before. Every Windows application needs one, and this is what handles the event loop. So the first thing we're going to need to do in here is we're going to check if we should toggle our menu. So that's done pretty simply. We're going to check the W param. So if W param is equal to WM key down. So basically this means if a key is being pushed down, and actually it's ahead of me over here. So yeah, let's go ahead and get that going. Okay, so this looks pretty good, although I'm going to comment this out for now because I don't think that that's very necessary. We'll see, we'll test that later maybe, but essentially this is all we need for now, because what this is going to do is it's basically testing if a key is down and if the key is insert. Obviously you change this to any button you want. For example, if you wanted it on enter, then you'll change it to VK enter, or you wouldn't actually, because that's clearly not a key code. Okay, if it's enter, I actually don't know what you would set it to. Someone comment down below, but obviously we're already using end to uninject our cheat, so I'm going to pick the standard key that every cheat uses, which is insert. Now on insert, if insert is clicked, what we're going to do is we're going to toggle the menu. So if the menu was set to open, which it isn't actually, I'm going to by default set it to true, just so that it shows on first inject. Then it's going to be set to the opposite, so it'll become false, and I think that makes sense, right? Unless you're pants on head retarded, this should make sense to you. Now the next thing we need to do is we need to pass the information through to ImGui, and once again AI is ahead of me over here. It's just done like that, but there is a problem here, and as you can see, the problem is that we don't have ImGui impl32 winproc handler, but that's funny because we actually do. This function is defined inside of the header file of win32, so it's defined in here, but to get it into our source code, we are going to say extern result im32 winproc handler, just like that. And as I said, this is defined elsewhere inside of the ImGui header files or in the source files, and then basically that is going to allow us to call it. Now obviously this winproc doesn't have the other return path. It was only returning true, which meant that it was never returning anything else when this wasn't true. So now we just need to add a return call winproc a, just like that. And that completes our winproc. So all that's left to do now is to actually go ahead and hook it. And to hook it, it's pretty simple. So let's get started. Within our create function over here, the first thing that we are going to do is we are going to check if we have a valid DirectX11 device as well as a valid window handle. So that's done like this. Alright, so you should have something that looks like this. We're just going to check if these are null, and if they are, we are going to throw an error, because once again, we're going to crash if we continue like that anyway. So let's crash gracefully. Now to hook the winproc, as I'm saying, it's pretty easy, and that's done like this. We're going to set original winproc. Yeah, this is a thank you, Mr. Copilot. So we're going to reinterpret cast to a winproc, and what we are reinterpret casting is set window long pointer a, and we're going to pass in the window, we're going to pass in winproc, and we are going to pass in the actual hook to our winproc. But here we do not need this ampersand symbol, so let's get rid of that. And yeah, so what this is going to do is this is going to replace the current winproc with our custom winproc, and we are going to use that to toggle the menu, and then we are going to use that to pass the information down through to ImGui. But we only need to do that if the menu is actually open, right? Because why would we need input if we don't even see the menu? And if the menu isn't being shown, then we are just going to call a regular winproc a and move on with our day. Now, once again, AI is a step ahead of me here. We do need to update the destroy method, because obviously when we uninject the game, or when we uninject the cheat now, we are going to need to restore the original winproc. And that is done exactly like this. It's basically the opposite process of this, but we are going to restore into the one that we saved. And that completes our winproc hook. Okay, so now that our menu has input, it would be pretty useful to go ahead and actually make the menu. So now it's time to write a little bit of ImGui code. We're going to get started by calling the classic ImGui create context. Next, we're going to get a reference to ImGui IO, and we are going to use the reference to enable keyboard input. So this is if you want to have some sort of name input or text box or even keyboard controls within your menu. Pretty useful. So let's go ahead and keep that. Now we need to set our style. So I'm just going to, for simplicity, use style colors dark, just like that. And the last thing we need to do over here in create is we actually need to pretty much create the menu, right? And we do that by calling exactly that, what AI has suggested. We call the impl win32 init, and then we need to do the same thing for the DirectX11 init as well. So that's going to be impl DirectX11 init. And this time we're going to pass in D3D11 device and device context. So that's why I'm checking specifically those things: device, device context, and window handle. That's because that is exactly what we're using to initialize ImGui and its context. Now you will notice that these return bools, so it's probably wise to go ahead and check if these fail. That is not what I was trying to do. So let's go ahead and add a exclamation mark there, and let's throw failed to initialize ImGui like that. And then let's do the same thing right here. And don't forget this bracket over here, and perfect. So now we should have a fully working ImGui menu that has been initialized. Obviously, we're not rendering it yet, and we aren't destroying it yet. Speaking of destroying, let's go ahead and implement the destroying before we forget. So that's going to be pretty much the opposite of what we have going here. We're going to start out with ImGui, impl DirectX11 shutdown. So impl DX11 shutdown, just like that. And then impl 132 shutdown. And then we can use ImGui destroy context. And that is going to fully destroy ImGui and everything that it loved in a very harsh manner. And that is going to allow us to uninject very safely and cleanly. And since we're here, we might as well go ahead and implement our rendering. Over here is where you can call any of your ImGui rendering functions. But you do want to sort of use a bit of an include guard here, like this. You do want to check if your menu's open. That is if you even want your menu to be toggleable. But for, I think most people will want a toggleable menu. So we're going to check if the menu is not open, then we're just going to return early. And down here, we can actually add our menu code. Now, this is suggesting ImGui new frame. We will get to that. Ignore that for now. We're going to pretend that that has been called already. And if you have no idea what I'm talking about, so to make a menu or to make a window in ImGui, it's ImGui begin. So let's do that. Let's go ahead and add some text. Who cares about hello world? This is going to be hello cazz because that dude's pretty sick. And then we are going to go ahead and just ImGui end. So this is going to show a window with the title menu, which is horrible. So let's say epic menu. And it's going to have an X button that we can close it with. It's going to say hello cazz, and then it is basically going to stop. Well, it's not going to stop. That's just how we stop rendering a window. Okay, cool. And funny enough, that actually fully completes our menu right here. Now, all that's left to do is to go and render it in our hooks, and then just enable it in DLL main. So let's head over to hooks.cpp and hook present. Before we do that though, we are of course going to need to go ahead and include our menu now because we have a menu. So let's include the menu just like that. Okay, so starting off in present, we're going to do the following. Okay, so we're going to start by checking if the render target is valid, and if it isn't valid, we are going to use that new shiny function that we made a bit earlier, and we're going to create the render target. The reason we do this is because the render target gets destroyed in these two functions. So there's a chance that present gets called when the render target is actually null, so we should go ahead and create it there. Then the next step is we're going to check if the device context is valid, and if it is valid, which I realize I made a mistake here because we actually want to check if it's valid. So exclamation mark over here, no exclamation mark over here, and we are going to set the render target that we just created. That is pretty simple. This actually has to happen every frame anyway, but this is just a safety check in case somewhere along the line you accidentally set this to null or something along those lines. Now all we need to do is actually just render with ImGui. Okay, so you should have something that looks like this. We're creating a new frame with all of our implementations and stuff. Then we are calling menu render that we just made earlier. And then we are going to actually render the data with ImGui before calling the original function. Now, the reason I've set it up like this is so that in the future, we can have something like ESP render, right? So that way we can, or actually a better name for this is probably visuals. So yeah, we can have something like visuals render, and that's also going to be able to be within the same ImGui frame. So we can, of course, go ahead and render like our box ESP or our name ESP or skeleton ESP and things like that. That's coming in next video. So definitely subscribe, like, and yeah, look forward to that. Okay, we're actually very close to being done now. Now we need to handle the resize buffers hook. So that is also pretty simple. Down here, we're going to go ahead and check if the result succeeded, and if it did, we're going to destroy the render target, and then we are going to go ahead and destroy the ImGui data. So I believe that's ImGui impl DX11 invalidate device objects. No, wait, sorry, we need to create the objects as actually. Okay, there we go. If resize buffers succeeds, we are going to destroy the render target and we are going to create new ImGui device objects. And then we're just going to return. So that's that done. You will never ever have to touch that again, I don't think. Let me just remove these comments because we really don't need them. And the last thing that we actually need to do is in here, we are going to invalidate the device objects. So let me go ahead and copy paste this like that. And then we are going to change this from create to invalidate. And the last thing we're going to do is call interfaces destroy render target. We are invalidating everything down here and we are destroying things in create swap chain. And that's going to make it so that eventually when it comes back to present, we're going to recreate the render target in the correct sort of, resolution. So this is if you're going to change your game window, if you're going to change it from full screen to windowed or change the resolution. If you don't implement this fix over here, your game is going to absolutely freak out and you are going to hate life. So that actually, as far as I understand, as far as I remember, is everything that we needed to add for the menu. So now all we need to do is head over to your DLL main, and now we need to create the menu. Now the order of this is quite important. We need to create our menu before the hooks are called. So to do that, we are just going to add it over here. So menu, but we can't do that yet because we do need to actually include it, right? So let's go ahead and include the menu, and then we can go ahead and call the menu create. And then it should be done in the opposite order. So then over here we have menu destroy. And then over here we will have the same thing. So hooks dies first, because if hooks dies, then nothing running in hooks will be called. Then we can safely destroy our menu and then destroy our interfaces. Actually, what did I have in interfaces destroy? Okay, it was just the DirectX11 stuff. Okay, cool. So yeah, theoretically right now, we actually do have a working menu. So I'm going to go ahead and build just to make sure, the first step works. Build is always very important. Now, I will just reiterate, you probably do want to come to globals and change your menu opened to true just by default. This is going to be the default value. So do you want to show your menu when you inject or not? Or do you want it to be toggled, etc.? And another important thing is this has to be inlined. If it isn't inlined, you're going to have these horrific unresolved external error symbols or something like that. And it's really a pain. So avoid that. I have built already. It seemed like it succeeded, and I will catch you guys in game for hopefully a good experience. Okay, the time has come to inject, and fingers crossed, toes crossed, praise be to Allah. Okay, if this thing crashes, I don't know what I'm going to do with my life, but that's why it's not going to crash. So let me go ahead and make sure that I do in fact have a CS2 EXE, the correct one, selected right over there. And please, boom, look at that. There we go. Okay. Look at that. We have a menu that is being rendered within CS2. It looks beautiful. It is amazing. You can click on it. Now that little X thing that I was talking about earlier, that has to do with this. If I click the X, you'll see it closes. And we can toggle it with the insert key. Or at least you're supposed to be able to. Okay, looks like that is something that I need to fix. You cannot toggle it with the insert key. Let me go see what's happening there quickly. Okay, so I actually screwed something up over here. This is a bit backwards. So key down is actually on the message param. I don't know what I was thinking. So yeah, the message will be key down, which obviously makes a lot more sense. And then the L param is going to be the key, but I have L param wrong because that's actually the W param. So all you need to do is change from W param over here to message, and then change L param to the W param. So yeah, apologies for that, but it happens to the best, right? And I'm the best. So now let me go ahead and build this. We got our menu back, and now, as you can see, we can toggle it just like that. Isn't that pretty cool? Okay, cool. So it seems like it's working pretty well, but there is one problem. Your movement will be frozen when the menu's open, but your mouse still works. And that is the only thing that's left in the video. So let's go ahead and implement that very quickly. All right, so at this point you have a menu. It's beautiful. You can toggle it. It works, but there's a problem. When you open it in game, you cannot access your mouse, which pretty much makes the menu completely useless. This is my bad because I was actually supposed to show you how to do this during hooks, but I completely forgot. As I say, it's been a while since this video was started and it just wasn't fresh in my mind, but I'm going to show you how to do it right now. So you can actually have a perfect, fully working menu that'll be ready for the next part to implement your ESP. So to get started with this, the first step we're going to do is we're going to head over to globals. Now this is funny because I told you you weren't ever going to have to touch globals for the rest of this video, but you will. And the only change we need to make is we need to add another bool over here, and that bool is not going to be should exit, but it is going to be a beautiful boolean called relative mouse mode. So relative mouse mode basically is telling you, is the cursor visible or not? I don't know how else to explain it. Something like that. It'll make more sense when we are in game and it's working. So the next step is we are going to have to head over to our hooks, and we're going to have to add 2 extra hooks. So let's go ahead and do that. The 2 hooks that you're going to add are going to be mouse input enabled, which is going to enable mouse input, and it is going to be set relative mouse mode, which is going to unlock your mouse when you are in game. So you can actually click the menu and essentially mouse input will be disabled. So you won't be clicking on the game, but you will be clicking on the menu and you will be able to use your mouse. This will make a lot more sense when we are coding it. So let's move into our hooks.cpp and let's go ahead and implement these actual hooks. So scroll down to under your, which hook is it? Under your create swap chain hook, and we're going to add them both here. So go ahead and follow along. So for mouse input enabled, it's pretty simple. We're going to check if the menu is opened. If it is opened, we're going to return false, right? So this is going to stop input going into the game, right? So when you do click, you're not going to shoot. When you click on your menu, you're not going to shoot in game, right? I hope that makes sense. But if the menu isn't open, then we're just going to let the game do its thing and call the original function. Now, something that is very important to note is that this is a fast call. Okay, in hooks.hpp, these are both this calls, right? This call pointer. But in the actual implementation of your hook, both of them are going to be fast calls. So please pay special attention to that. Now, the other thing I wanted to say was that this has to be a void pointer. So please be careful. It's pretty easy to mix it up and forget that this should be a void pointer. And finally, you're using CSGO input for the first one and you're using input system for the second one. Those are 2 different things. And CSGO input is not a mistype. That is actually what it's called in game. Let's head back to hooks.cpp and let's implement the second function. Okay, so set relative mouse mode is going to be pretty simple as well. Not as simple as input enabled, but basically we're going to store the relative mouse mode every time that this is called. We're going to store that in our global variable over there in the globals file. And then we're going to call the original, return the original actually. And yeah, we're going to check if the menu is opened. And if it is, we're going to say false. Otherwise, we are just going to go ahead and return the state that was passed through over here on the enabled bool. So that pretty much sums it up for the implementations of our hooks. Now we just need to go and place them. So let's scroll down to our create function over here and let's scroll down all the way to the bottom to before mh enable hook, and we're going to place both our hooks over here. So just like pretty much all the other hooks, we're going to use mhCreate hook and we're going to use virtual function get. And this time we're going to use those interfaces that we got right in the beginning of the video. So the first one is going to be CSGO input, and that's going to be mouse input enabled at index 15. So remember to make sure that everything corresponds correctly. And then yeah, the second one is going to be index 76 of the input system. And once again, make sure everything is correct and make sure you do have these ampersands, or else once again, you will run into problems. And that should actually be it for hooking. So now that we have those hooked, the last step is to head over to our menu.cpp file, and we do need to make a little bit of a change over here. Inside of your WinProc, inside of your menu toggle, after the menu is toggled, we actually need to go ahead and update the relative mouse mode. So that is done like this. Oh, actually, first, make sure that you have included hooks, right? We haven't used hooks in this yet, and there's a reason why hooks was included. That is because of this. So go ahead and follow along, and I will talk about it in a second. Okay, so all you're going to do is add this line over here, or for me it's 2 lines, and that's going to be calling the original set relative mouse mode function, and you're going to pass in the interface's input system, because remember we don't have an input system being passed in over here, so we have to use our interfaces one, and then we're just going to check if the menu is opened, and if it is, we're going to return false. Otherwise, we're going to return the cached value or the saved value that we've been using. So yeah, I believe that is actually everything. So I'm going to go ahead and build again, and I will catch you in game to show you that the input system is now working completely correctly. Okay, so we're in game over here. As you can see, game is working fine. Just to wreck this noob quickly. Okay, let me go ahead and add CS2 over here, and let me inject. And now you'll see that I do not interact with the game. Let me put the menu away, and I've cooked something. Alright, ladies and gentlemen, I've discovered what the problem was, and it's pretty silly, like most problems. But remember, when we toggle the menu with the menu button, afterwards we are calling the original set relative mouse mode, right, which fixes the relative mouse mode and makes it what it should be. Now, the problem is, if you remember, down here we had the extra bool over here, just like this, which gave you the little X mark on the menu that would let you, let me see if I have the menu over here. No, I'm not injected right now. But that if you click that little X, you would close the menu, but you weren't calling this function over here, right? You weren't calling the original to fix this problem. So basically, the solution to this is we are just going to remove that little X. And if you want to use that close button that is on the actual ImGui window, then what you need to do is when it's closed or something like that, you need to check and see if the state of that bool has changed. And if it has changed, you need to manually go ahead and call this method, right? Or this function rather. So yeah, that's the problem. If you just remove it like that, and then let's go ahead and build and inject. As you can see, we have the mouse in the game. And then if I toggle the menu, we can access the mouse in the menu and not the game. And then we can put the menu away, and just like that, it works how it should work. So anyway, ladies and gentlemen, I really hope that you enjoyed the video, and I really hope that you did get a working CS2 internal menu out of it. This video has taken me a long time to make, and I apologize for the massive delay in uploads and everything like that. I've just been very busy with real life. But yeah, look forward to the next part of this tutorial series next month, which will be ESP. We're going to add some special types of ESP, and we are actually going to we're going to dive deeper, much deeper into the input system, sorry, not the input system, into the interfaces, and as well as making a schema system, so you have auto updating offsets and all sorts of things. So yeah, if you liked the video, definitely drop a like, subscribe, and as always, the source code will be available on Patreon. So yeah, thanks for watching, and see you in the next one. Cheers and peace out, ladies and gentlemen.